Hello everyone, this is Meenakshi Dilip Birari, working as an assistant professor in chemistry at Maratha Vidya Prasarak Samaj, Nasik. Today we are going to start the next unit of industrial chemistry, that is manufacture of basic chemicals. In India, the chemical industries stand apart in all manufacturing industries in terms of their utility to common man and importance to the nation. Many of their products are used in manufacturing industries in India. For example, chemical industries supply the materials for the preparation of food materials, drugs, polymers, textiles, dyes, building materials, etc. Ammonia, sulfuric acid, and nitric acid are some of the basic chemicals produced by chemical industry and which are used directly or indirectly as a fertilizers or as a intermediates for the preparation of other chemicals. So, in this unit we have to study the manufacture of ammonia, sulfuric acid and nitric acid. Today I am going to talk about manufacture of ammonia by Haber process. In this unit we have to study the manufacture of ammonia by modified Haber-Bosch process, physico-chemical principles involved and its uses. We have to study the manufacture of sulfuric acid by contact process, physico-chemical principles involved and its uses. Also, we have to study the manufacture of nitric acid by Ostwald's process, physico-chemical principles involved and its uses. The manufacturing of desired product required many types of chemicals as raw materials. For example, chemical industries supply the materials for the preparation of food materials, drugs, polymers, textiles, dyes, building materials, etc. Ammonia, sulfuric acid, nitric acid are referred to as the basic chemicals and are manufactured in bulk quantities. These are used both in organic and inorganic chemical industries. So, these basic chemicals are produced by chemical industries and are used directly or indirectly as a fertilizers or as a intermediates for the preparation of other chemicals. Ammonia can be manufactured by using modified Haber-Bosch process, sulfuric acid by contact process and nitric acid by Ostwald's process. So in this unit we have to study in detail the manufacturing of ammonia, sulfuric acid and nitric acid. Today I am going to talk about the manufacturing of ammonia by Haber process. First of all, what is the structure of ammonia and the IUPAC name of ammonia, properties of ammonia. Ammonia is an important compound of nitrogen and hydrogen. It is one of the most common hydride present in the atmosphere. It is produced by the natural decomposition of animal and vegetable bodies. Ammonia also occurs in the soil in the form of ammonium salts. The IUPAC name of ammonia is azane and the chemical formula of ammonia is NH3. So it is the structural formula of ammonia. In this center nitrogen and 3 hydrogens are there. So we should remember the IUPAC name of ammonia, that is azane, and the chemical formula is NH3. It is the structural formula. There are various properties of ammonia. These are molecular weight 17 gram per mole, boiling point minus 33.34 degrees Celsius, freezing point minus 77.7 degrees Celsius. Ammonia is soluble in chloroform, ether and ethanol. It is having density 0.769 kilogram per meter cube at STP. Now what is the principle involved in manufacture of ammonia? The manufacture of ammonia is based on the principle that nitrogen and hydrogen react in the volume ratio 1:3 under pressure and at optimum temperature in presence of a catalyst. So the manufacturing of ammonia, it occurs by using two reactants like nitrogen and hydrogen in the ratio 1:3 under pressure and at optimum temperature in presence of a catalyst. So what is the reaction for manufacturing of ammonia? It involves 1 volume of nitrogen, 3 volume of hydrogen, which give the formation of 2 volume of ammonia, that is NH3. So 1 volume of N2, 3 volume of H2 give the formation of 2 volume of NH3. So we should remember the volume ratio of nitrogen and hydrogen 1:3. 1:3, there is the formation or manufacturing of ammonia. So it is the reaction involved in the manufacturing of ammonia. Now what is the process in manufacturing of ammonia? Depending upon the source of reactants, which are hydrogen and nitrogen, the processes are named as Haber process, and second one modified Bosch-Haber process. So Haber process, in this process the nitrogen is obtained from liquid air and hydrogen which is obtained from steel, hydrocarbon or electrolytic process. Modified Haber-Bosch process, this process is also called as a Bosch-Haber process. In this process, nitrogen is obtained from producer gas and hydrogen is obtained from water gas. Today I am going to talk about Haber process in detail. So let's see in detail about Haber process for manufacture of ammonia. So what is Haber process? Haber-Bosch process or just Haber process is basically one of the most efficient and successful industrial procedures to be adapted for the production of ammonia. German chemist Fritz Haber, along with his assistant in the 20th century, developed high pressure devices and catalysts to carry out the process on a laboratory scale. After that, Carl Bosch in the year 1910 took the design and created a machine for industrial level production. This was indeed an important development in the field of science. So we have to describe in detail the manufacturing of ammonia by Haber process. In the Haber process, the atmospheric nitrogen N2 is converted to ammonia, that is NH3, by reacting it with hydrogen H2. So here a metal catalyst is used and high temperature and pressure are maintained. The raw materials for the processes are air, which supplies the nitrogen, natural gas and water, which supply the hydrogen and energy needed to heat the reactants. Iron, which is the catalyst and does not get used up. So already we know that catalyst, it recovers the reaction. After completing reaction, the catalyst is regenerated. It is also used for another process. So for the manufacturing of ammonia in Haber process, the atmospheric nitrogen and hydrogen are used to form NH3. So air, which supplies the nitrogen, natural gas and water, which supply the hydrogen, and also the energy which is needed to heat the reactants, and catalyst used in this process is iron. So we should remember the raw materials for the process: air, which supplies the nitrogen, natural gas and water supplies the hydrogen, and catalyst we have to use iron for the manufacturing of ammonia in Haber process. So it is the flow scheme of Haber process. So in this process, again we can represent the nitrogen, which is one of the raw material from the air, hydrogen from the natural gas, N2 and H2 combines in the ratio 1:3 by volume. So 1 volume of nitrogen, 3 volume of hydrogen combines to form the ammonia, that is NH3. So for this manufacturing, the atmospheric temperature and pressure are maintained. 400 to 450 degrees Celsius temperature, 200 atmospheric pressure, and the catalyst used for this process is iron. So after that there is the formation of gas, and that gases of ammonia are cooled and ammonia turns to liquid. So we get the manufacturing of ammonia in the form of liquid. So here N2 gaseous, H2 gaseous by 1:3 volume give the formation of liquid ammonia. So it is the flow scheme of Haber process. So as per the diagram, in the Haber process we take nitrogen gas from the air and combine it with hydrogen atom obtained from natural gas in the ratio 1:3 by volume. The gases are passed through 4 beds of catalyst with cooling take place in each pass. This is done to maintain the equilibrium constant. While different levels of conversion occur in each pass where unreacted gases are recycled, normally an ion catalyst is used in the process, and the whole procedure is conducted by maintaining a temperature of around 400 to 450 degrees Celsius and pressure of about 150 to 200 atmosphere. So we should remember the condition for the manufacture of ammonia by Haber process. The catalyst iron is used and the temperature of about 400 to 450 degrees Celsius, a pressure of about 150 to 200 atmosphere. The process also involves the steps like shift conversion, carbon dioxide removal, steam reforming, and methanation. In the final stage of the process, the ammonia gas is cooled down to form a liquid solution, which is then collected and stored in the storage containers. So it is the manufacturing by Haber process. N2 reacts with thrice H2 to give twice NH3. That means the ammonia gas is cooled down to form a liquid solution, which is then collected and stored in storage containers. So catalyst use iron, temperature 400 to 450 degrees Celsius, a pressure of about 150 to 200 atmosphere. So first step of manufacturing of ammonia, in that hydrogen, which is made from natural gas by steam reforming. Here is the reaction. CH4 gases plus H2O in the presence of nickel catalyst give the formation of CO plus thrice H2. Then the gaseous products are mixed with more steam to give the formation of H2. So this one CO plus thrice H2 plus H2O in presence of Fe2O3 catalyst gives CO2 gaseous plus 4H2 gaseous. This CO2 is removed by dissolving it in H2O under pressure. So we get the formation of hydrogen, which is one of the raw material for the manufacturing of ammonia. Then step 2 for manufacturing of ammonia, nitrogen, which is made by fractional distillation of liquid air or by burning hydrogen in air. So this one is the reaction. In this, twice H2 plus O2 plus N2 give the formation of twice H2 gaseous plus N2 gaseous. So this nitrogen is made by fractional distillation of liquid air or also by burning the hydrogen in air. So that is the second step of manufacture of ammonia. Step 3, manufacture of ammonia. Dry nitrogen and hydrogen Both are mixed in volume proportions of 1:3, pressurized to 200 atmosphere and passed over an ion catalyst at 500 degrees Celsius. So N2 gaseous plus thrice H2 gaseous in presence of ion catalyst at temperature 500 degrees Celsius at 200 atmospheric pressure give the manufacturing of ammonia 2NH3 gaseous. So 1 volume of nitrogen, 3 volume of hydrogen give the formation of 2 volume of ammonia. Then the ammonia is liquefied by cooling and separated from any unreacted gases which are recycled. So that is the third step of manufacturing of ammonia. Let us see reaction rate and equilibrium involved in the manufacturing process. The Haber process for the synthesis of ammonia is based on the reaction of nitrogen and hydrogen. The chemical reaction is given below. Already we have studied N2 gaseous plus thrice H2 gaseous give the formation of twice NH3. In this process the reaction is an exothermic reaction, one where there is a release of energy. So it is called as a exothermic reaction. There is a release of energy. So this N2 reacts with thrice H2 give the formation of twice NH3. Nitrogen in the reaction is obtained by separating nitrogen from air through liquefaction, and hydrogen is obtained from natural gas by steam reforming. So this one is the reaction. CH4 plus H2 give the formation of H2 plus CO, carbon monoxide. So this one is the block diagram related to the Haber process in which N2 and H2 combines to form NH3. Firstly, we obtain the NH3 gaseous. Then by cooling it, there is the formation of liquid solution of ammonia in presence of catalyst ion. Ion catalyst is used in the manufacturing of ammonia by Haber process. According to Haber, the commercial synthesis of ammonia is possible if the mixture of N2 and H2 is pressed to 200 atmosphere and passed over heated catalyst kept at 500 to 550 degrees Celsius. So then the yield obtained in this process is about 8% by Haber process for ammonia. So according to Le-Chatelier principle, the production of ammonia is favored by high pressure and low temperature. The Haber process is typically carried out at pressures between 200 and 400 atmosphere and temperature of 500 degrees Celsius. In the commercial production of ammonia is continuously removed as it is produced. Removing the products causes more nitrogen and hydrogen to combine according to Le-Chatelier's principle. So here according to Le-Chatelier principle, the production of ammonia is favored by high pressure and low temperature. So if we maintain the temperature lower and higher pressure, then there will be the manufacturing of ammonia. The reaction, it is a reversible reaction. However, the reaction is also affected by changes in temperature, pressure and catalyst used mainly in the composition of the equilibrium mixture, the rate of the reaction and also the economics of the whole process. But this Haber process also having the limitation. The main limitation of Haber process is that the yield of ammonia is low, that is about 8%. So by using this Haber process, the manufacturing of ammonia is carried out, but the yield of ammonia, it is very low, that is about 8%. The yield of ammonia could be so increased that economically synthesis of this product become profitable. Haber first tried the osmium and uranium as a catalyst, but they were found to be costly and susceptible to poisoning. So he found the another catalyst, that is finely divided iron with a promoter like molybdenum or a mixture of Al2O3 and K2O. So to avoid such type of the limitation, for the manufacturing of ammonia, the another process, that is modified Haber-Bosch process. So that process we will see in detail in next lecture. So these are the questions related to this topic, that is manufacture of ammonia by Haber process. So we can solve such type of the questions related to this topic. How can nitrogen be obtained from liquid air? And by compressing liquid air, by fractional distillation of liquid air, by passing liquid air over nickel catalyst, by adding carbon dioxide to liquid air. The second one, choose the conditions that would give highest yield of ammonia using the Haber process. So already I have explained what are the conditions to obtain the higher yield of ammonia by using Haber process. So this question is based on the Le principle. High temperature, high pressure, or low temperature, high pressure, like that. These are the conditions. So you can test your knowledge by solving such type of the questions. So in detail we have studied the manufacture of ammonia by Haber process. In next lecture we will see in detail the modified Bosch-Haber process for the manufacturing of ammonia. Thank you.